Hello everyone. So in this lesson we're really just going to focus on doing a really quick review over quadratics as a whole. So there's going to be a ton that's going to go into quadratics, but because this should really be a review, I'm just going to kind of graze over a lot of this. So just kind of getting started, we're going to look at a parabola in just its different parts. So when you have a parabola, whether we have a minimum or a maximum of a parabola, that minimum or the maximum we refer to as the vertex. And then through the vertex, we have this vertical dashed line that's going to make a symmetric parabola, and that's what we refer to as the axis of symmetry, or the AOS. And then wherever your parabola crosses the y-axis, of course, that's what we're going to refer to as the y-intercept. And then the x-intercepts of your parabola, of course, you can call them the x-intercepts, but more specifically, we do have some other names. So the other names we may refer to are roots, zeros, and or solutions. So those names are going to be pretty synonymous with each other, so just know that we may switch up the wording, but we're still referring to the same thing when we refer to the x-intercepts. Now, with your x-intercepts, those are also referred to as solutions. So when we say that your parabola or quadratic may not have a solution, well, that just really means that it doesn't cross the x-axis. So your parabola needs to cross the x-axis in order to be, or to have what we call solutions. So not all your parabolas are going to cross your x-axis, which means we're going to have what we call complex or imaginary solutions, which we're going to get more into detail on that later. So with your quadratics, we have several forms that we've seen before, or hopefully. So you've hopefully seen vertex form, polynomial form, which we refer to as standard form, which has typically been in the form of this. And then we also have factored form, which we're going to get heavy into factored form in a bit, but just want to kind of throw all these forms out there. And then here are all the different ways in which you could find said attributes in said form. So I'll let you guys take a minute to kind of read and glance over this. Now down here, I've already kind of pre-filled out a lot of this information because this isn't where I want to spend too much time, but it kind of gives you an idea of what we expect, how you solve these problems, and what we're going to be using in the future. So we're going to actually be using a lot of these ideas here in the next unit or two when we do polynomials. So I'll kind of give you an idea, kind of glance over all this information, but I'm actually going to work the examples on the next page with you. So one of the few ways that we're going to be looking at is just traditional solving. Now when I say traditional solving, that just means you're going to do your inverse operations. So for example, if I have x squared minus 49 equals 0, you can solve this quadratic just by solving an equation. So for example, first step here is you would add 49 on both sides. So that's going to leave us with x squared equals 49. And then in order to undo your squared, what you're going to do is take the square root of both sides. So that's going to leave me with x is equal the square root of 49. Now, a very, very important detail, when you take the square root of both sides, you need to include both the positive and the negative value of that number. And then once you take the square root and you include the plus or minus, then you can evaluate and simplify. So this would just give you plus or minus 7. Now over here, same idea. So we have negative 3x squared minus 18 equals negative 30. We're still going to do your inverse operations, so I'm going to add 18 on both sides. So we get negative 3x squared. It's going to equal negative 12. Next, you're going to divide by negative 3, which is going to give you x squared. It's going to equal positive 4. Now, once again, we need to take the square root of both sides. And then because we're doing the square root, you need to include both the positive and the negative of that square root, which in this case is a perfect square, which is just 2. So x is plus or minus 2. Now over here, so I'm going to do this one on purpose just because I know it's a lot like the first one, but it adds a bit of an extra step. So with this one, you're still going to add your c value, which is 75. We're going to move it to the other side. So that's going to give you x squared is equal to positive 75. And then when you take the square root of both sides, of course, we're going to include plus or minus, but 75 is not a perfect square. So you're going to have to be able to break this number down. So I'm going to do this a couple different ways just to kind of give you some options. I do have a preference which one I prefer, but I want to give you guys some options to work with. So the first option is I'm going to do a factor tree. So we're looking for two multiples that result in a product of 75. So first I think of quarters. So we have 3 quarters. So 3 times 25. And then 25 breaks into 5 and 5. Now, once you do your prime factorization or your factor tree here, once that number breaks down, you no longer need it. So that 75 broke down into 3 and 25. 25 broke down into 5 and 5. So we only have a 5, 5, and 3. So those 3 numbers multiply to give you 75. Now, when you are simplifying your radicals, what you're looking for are pairs. So I have a pair of 5s, and then I have a leftover 3. So the pair number is going to be written on the outside just one time, and then your leftover gets written on the inside of the radical. So the square root of 75 is going to be equivalent to 5 root 3. So this would be what we're looking for. So the other way that I do want to show you, which I've seen some people do this one, so they actually start with, they just start with the square root of 75, and then they're going to break it apart, similar to what I just did, but just in a different visual. So 75 can break into 3 and 25, and then, once again, 25 breaks into 5 and 5. That's a 3, I promise. So 3 times 5 times 5. And then what I've seen some educators do is then they look for pairs on the inside, and then that pair number is what comes out. And you'll write it in the front. So then this would be rewritten with that 5 on the outside, and then that 3 did not have a pair, so it stays in the inside, and then this is how you would rewrite it. So however you want to do it, it's really up to you, but personally I like the factor tree, but that's just me. So we're going to use a lot of those ideas when we move on to the next part. So in this next part, we're going to be doing factoring. Now, a very important part about factoring I want to stress is you have to do factoring by grouping. It has to be grouping. So we're not doing any like slide and divide or whatever the other tricks are that you may have been taught. This being an AP course, or if you're in this AP course, you have to do grouping. You have to show that you know how to do this in a mathematical way. So not saying the other ways don't work, but they may have caveats that don't make them work all the time, whereas grouping does work all the time. And because you're doing an AP exam, you have to show a mathematical method. So we're going to do all these by grouping. So with grouping, the first thing you're going to do is you're going to look at your A value and your C value. So my A value over here is just going to be 1. So we're going to do A times C, which is going to be 1 times 12, which is just going to give you 12. So with this, now I need to find the factors of 12 that are going to add to give me -8. So include that negative if that negative is there. So my factors of 12, we have 1 and 12, 2 and 6, and 3 and 4. So I can see that my values need to multiply to a positive. So that means both factors either should be a positive positive or they need to be a negative negative. Now if my factors add to a negative, that means I need 2 negatives. So what that tells me is I'm going to make all my factors here negative. So with this, I'm looking for the set of factors that adds up to a -8. So the only set that adds up to -8 would be -2 and -6. So I'm going to use those values to do what I call split the middle. So when I split the middle, I'm leaving the first and this last term, I'm leaving these alone. I'm only going to change and edit this middle term, which is the middle. So I'm going to have x squared, or try to, see if I can write. So x squared, and then I'm going to change the -8x into -2x minus 6x, and then plus 12 equals 0. So the order in which you write the -2x or the 6x, it doesn't matter. It would just change one step later on, but it doesn't give you extra steps. It just changes a step. So once you get here, now the next step is now I'm going to do my grouping. So I'm going to rewrite my equation. And when you get here, I'm going to group the first two terms together and then group the last two terms together. And then once you do your grouping, you're going to do your greatest common factor. So out of x squared minus 2x, I can take out an x. And what that leaves me with is x minus 2. And then in the second group, a negative 6x plus 12. If your first term here is negative, you have to take out a negative. So I know I need to take out a negative. And then between 6 and 12, I can take out 6. So I'm factoring out a negative 6. And that leaves me with x minus 2. Now, another very, very crucial, important part here is when you do your grouping, these two binomials that I have here, they need to be the same. They need to be equal. If they're not equal, that means you did something wrong, and you need to go back and redo your greatest common factor. So when you get to this part, now that those are the same, I'm actually going to take those x minus 2's, and I'm going to take them out and do another greatest common factor. So when I take out that x minus 2, what that leaves me with, so these would then go away, which is going to leave me with x minus 6. So these would be, or this right here, the x minus 2, x minus 6, this would be your factored form. And because we're solving, we need to keep going. So if I'm solving, I'm going to take each of these binomials, and I'm going to set them both equal to 0 and solve. So x minus 2 equals 0, x minus 6 equals 0. That is an equal sign. There we go. So when you solve these individually, so we're going to get an x value of 2 and an x value of 6. So both of your solutions, I personally like to write them with a separation of a comma. So 2 and 6. There we go. So I did that one step by step, so I would invite you to try these on your own. It's going to follow the same process, but the a value is not 1 in this case, and we do have a little bit more of a setup. So I'm actually going to go through number 7 with you, just to do the setup. So I need these to be in standard form, which is polynomial form, which I need it to look like this. I need everything on the same side. In your setup, your entire polynomial, or quadratic rather, it needs to equal 0. Your y value when you're solving is going to equal 0. So that's what I want to do down here. So what I need to do is this 5x, I need to move it over. So I'm going to subtract 5x on both sides. Now I cannot combine it with anything that's already here, so it's just going to turn into 2x squared minus 5x minus 12 equals 0. And then from here, once again, we're going to do our a times c. So my a times c is going to be equal to 2 times negative 12, which is going to give me negative 24. So I want factors of negative 24 that are going to add up to my b value, which is negative 5. So factors of negative 24, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now keep in mind, these multiply to a negative, which tells me we either need a positive negative or a negative positive combination. So if you look, they add up to a negative. So if your two values add up to a negative, that means your bigger number has to be negative. So in this group over here, I'm going to make all the bigger factors negative. And now I'm looking for the factors that add up to a negative 5. That would be 3 and negative 8. So I'm going to split the middle using 3 and negative 8. So once again, I'm going to leave the first and the last term alone. So 2x squared. And then once again, the order doesn't matter. Let me actually do negative 8x first. Oops, there we go. So let's do negative 8x first, and then plus 3x. Let's just switch up the order, because why not? So now that I have this, now that I split the middle, now I'm ready to do my grouping. So over here, I rewrote it in all black so that you can get a better idea of the colors with grouping, but you don't have to rewrite it if you don't want to. So I'm just going to go right into grouping. So I'm going to group the first two and the last two. So in the first group, 2x squared and negative 8x, I can take out a 2x. When I take out a 2x, that leaves me with x minus 4. And then in the second group, 3x minus 12, I can take out a positive 3. And that's going to leave me with x minus 4. Now, once again, my binomials in the parentheses here are the exact same, so I'm good to go. So I'm going to take out x minus 4, and then I also have the 2x plus 3. So now I'm going to take these individual factors, and I'm going to solve them. So x minus 4 equals 0, and then 2x plus 3 equals 0. So when I solve these individually, so I'm going to have an x value of 4, then subtract the 3, divide by 2, so that means my x value here would be negative 3 halves. So here are my solutions. So when you are doing any sort of solving by factoring, you just have to make sure that you are doing factoring by grouping specifically. All right, now down below, now we're going to do completing the square. So completing the square is just another way of solving. So with completing the square, the first thing that you need to do is we need to make sure that your a value is equal to 1. In this case, it's already equal to 1, so we're good on this front. So the next step is you're going to add your c value to the next side. So I'm going to add 21, add 21. So doing this, that's going to give us x squared plus 4x. And now I'm going to have this little box right here. This is going to be used for completing the square. And that's going to be equal to 21 plus that same value that we're going to put over here. So in order to find what goes in this little mystery box, this is where you're going to do completing the square. So to complete the square, we're going to do b divided by 2, and then you're going to square that value. And that's what's going to go in those boxes. So that value, your b value that I'm going to take is going to be that positive 4. So I'm going to do 4 divided by 2, and then square it, which in this case, 4 divided by 2, which is just 2, squared, which is equal to 4. So that 4 is what you're going to write in these boxes. So now I'm going to bring down my equation over here. And then I'm going to go ahead and consolidate and combine like terms over here. So 21 plus 4, which is going to give me 25. And now on the left side over here, this will always be what we call a perfect square trinomial. That perfect square trinomial is going to factor into a binomial squared. So in order to figure out what's going to go inside of these parentheses, what I do is I do the square root of the first, which is just going to be x. You're going to keep the sign of your b value, which is positive, and then I want the square root of the last. So the square root of 4, which is just going to be 2. And then that's going to be equal to 25. So we're going to have x plus 2 squared equals 25. So now this is what I want to solve. So just like before, we're going to take the square root of both sides to get rid of that squared first. So that's going to leave me with x plus 2 equal, and don't forget your plus or minus, and then the square root of 25, which is just going to give us 5. So now I need to subtract the 2 over. So this is going to give us x equals negative 2 plus or minus 5. Now this can be expanded, so meaning I'm going to do one solution with subtraction, and then I'm going to do one solution with addition. So negative 2 minus 5, which gives you negative 7, and negative 2 plus 5, which gives you 3. So these are going to be our two solutions. So negative 7 and 3. Okay, and then next, let's actually go ahead and do 11, since this one has a lot more going on with it. All right, so first thing is I need to get it in the form of ax squared plus bx equals c. So my c value, which is just my constant, is already over here. So I need to move my bx term over here to be with my ax squared term. So I'm going to subtract 8x. So that's going to leave me with 2x squared minus 8x equals 18. And then another, I guess, issue or stipulation we have to follow is your a value needs to be a 1. Right now it's a 2. So what that tells me is I need to divide everything by 2 so that that a value can be 1. So that's going to leave us with x squared minus 4x equals 9. And then we're going to follow the same steps. So I'm going to leave a space to complete the square. So in order to complete the square, now I'm going to use this negative 4 right here. So my b divided by 2 squared. So we're going to have negative 4 divided by 2, all squared. So that's going to give you negative 2 squared, which is still positive 4. So that's what's going to go in these boxes. Now I'm going to bring down the equation. So we've got x squared minus 4x plus 4 equals, and then 9 plus 4 over here is just going to give you 13. So now I need to factor the left side. So once again, it's going to be a binomial squared, and that's going to equal 13. So this is, the left side should always factor into a perfect square trinomial. If it doesn't, you did something wrong. So square root of the first, which is x. I want the sine of the b, which is minus, and then I want the square root of the last, which is 2. So x minus 2 squared equals 13. So now I'm ready to solve it. So I want the square root of both sides. So x minus 2 equals plus or minus square root of 13. Now, square root of 13, that's not a perfect square, and it can't be simplified, so you're just going to leave it how it is. And then I'm going to add 2 on both sides. And then that 2 I'm going to write in the front so that we can write it as x equals 2 plus or minus the square root of 13. So this would be what we're looking for. Now, if this radical right here, if this 13 was a number like, I don't know, 12, 24, 48, or anything like that, where it could branch and simplify, kind of like what we did up here, then you will be expected to simplify that radical. Okay, moving on. Now we're going to look at quadratic formula. So your quadratic formula, hopefully this is not new. So x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac. And that's going to be all over 2a. So hopefully you either have it memorized or you have some sort of mnemonic to help you remember it, but let's go. All right, so starting off, your a, b, and c values need to be identified. So I know my a value here is 1, b value here is negative 14, and then my c value here is 40. So then you're just going to plug in. So x is equal the opposite of b, which means positive 14, plus or minus the square root of your b value squared, so negative 14 squared, minus 4ac, all over 2 times your a value. So now we're just going to simplify. So we're going to have 14 plus or minus the square root of negative 14 squared, which is going to be 196. And then minus 4 times 1 times 40, which is going to be minus 160. So that's going to be all over 2. And then when you subtract, so 14, my handwriting is so bad. 14 plus or minus square root 196 minus 160, which that's going to give you 36. And that's going to be all over 2. And then let's actually do this. So I can actually find the square root of 36. So that's going to be 14 plus or minus 6 all over 2. And then here, this is where you're going to, what I call separate. So I'm going to have one solution where I'm doing subtraction, and then another solution where I'm doing addition. So 14 minus 6 over 2, and then we're also going to have 14 plus 6 over 2. So when I simplify, so 14 minus 6, which is going to give us 8, over 2, which simplifies to 4. And then 14 plus 6, which is going to give you 20 over 2, which simplifies to 10. So your two solutions here, we're going to have 4 and 10. All right, so 13 and 14 are going to be the same idea. It still follows the same schematics and methods up above. So just know that if you do get a radical here that is not a perfect square, you are going to be expected to simplify and rewrite and then simplify the fraction as needed. So I'm going to go ahead and do a couple of these applications. So the first one we have here is going to be the sum of a number and its reciprocal is 26 over 5, and you want to find the number. So when I say the sum, hopefully you know, the sum just means we're going to add two numbers, and then we have just the sum of a number. We don't know what that number is, so that's where I'm going to say x, which is our variable. And then when I say the reciprocal, that is making it into a fraction. So I want that number, but it's reciprocal, so that's 1 over x. And of course, when I say is, that's just a fancy way of saying equals. So when I set up, so the sum of a number and its reciprocal is equal to 26 over 5. So this is your setup. So, of course, there's a bunch of different ways that you could solve this. I'm going to do this the way that I'm most comfortable and most confident with personally. So what I'm going to do is I want to eliminate these denominator values. So in order to eliminate the denominators, what I'm going to do is actually multiply both sides by 5x and 5x. And then I'm going to distribute. So this is going to give me 5x squared plus 5, and that's going to equal 26x. So then when you get here, I'm going to move over the 26x. So I have 5x squared minus 26x plus 5 equals 0. And then I'm going to factor. So I'm going to skip kind of the factoring part, but 5 times 5 is going to give you 25. Factors of 25 that add up to negative 26. Well, that's going to be a negative 1 and a negative 25. So 5x squared, split the middle, minus x minus 25x, and then plus 5 equals 0. So I'm going to go ahead and do my grouping. So in the first group and the second group. So in the first group, I can take out an x, which leaves me with 5x minus 1. In the second group, I can take out a negative 5, which is going to leave me with 5x minus 1. Whoops, this should have been pink. There we go. I'm trying to be consistent with my colors. So now I'm going to take out the 5x minus 1, and that's going to leave me with x minus 5. So now I'm going to take both of those equations and solve. So 5x minus 1 equals 0, and x minus 5 equals 0. So I'm going to add 1 and then divide by 5. So we're going to have an x value of 1/5, and then over here, an x value of 5, which is going to be consistent because we have 5 and 1/5, which are reciprocals. So both of these numbers will work. So you want both. All right, and then on 16, I'm just going to do the setup on this one. I'm not going to solve it completely. So we have the product of two consecutive odd. So when I say product, that tells us that we're going to be multiplying these values. Two consecutive odd numbers. Now, I know the setup on this one can be a little wonky, so I'm going to kind of do a visual. So if I do just a simple little number line over here. So if I want consecutive odd numbers, that means I want 1, 3, 5, 7, 9. So if I say that my first number is 1, in order to get to the next number, I'd have to do this number plus 2, which means my values here are going to be x and x plus 2. And that's going to work no matter which set of consecutive odd numbers that I use. So over here, the product of two consecutive odd numbers is 255. So my setup, we're going to do x times x plus 2, and that's going to be equal to 255. And then from here, then you would distribute the x, so we have x squared plus 2x equals 255. You're going to subtract the 255 over, and then that's going to be equal to 0. So here, you can do factoring, which, if you really want to, do you really want to find all the factors of 255? Probably not. That's probably a lot. So this is actually one of those cases where I think factoring may not be the best option. So my recommendation here is actually to do completing the square. So if your number here is too big, I would recommend doing completing the square instead. So I'm going to rewrite it. I guess I am going to go ahead and solve it. So 2x plus your mystery value equals 255 plus my mystery value. So my b value for completing the square is just going to be 2. So I'm going to do 2 divided by 2 all squared, which is just going to give you 1 squared, which is just 1. So 1 is what I'm going to put. So that's going to leave me with x squared plus 2x plus 1. And that's going to equal 256. Now 256, that is a perfect square. So on the left side, I'm going to factor this to a perfect square trinomial and then take the square root eventually. So let's actually do the left side first. So this will turn to x plus 1 squared equals 256. Now I can do the square root. Just getting a little ahead of myself. So this would be x plus 1 equals plus or minus 16. And then when I subtract, so negative 1 plus or minus 16, which means we're going to have negative 1 minus 16 and negative 1 plus 16. So your two sets, so I would have negative 1 minus 16, which means x is going to be equal to negative 17, and negative 1 plus 16, which is going to be equal to 15. So my sets here, if I were to look at the consecutive odds, that means we're going to have negative 17 and then negative 15, but also 15 and then 17 for those consecutive odds. So we have two sets. So that's kind of a really quick recap of all the quadratics. I know that was kind of a lot to do, but there's just a lot of information and a lot of techniques and concepts that we're going to be using in the future. So have fun.